Okay, welcome everyone. Today is Sunday, right? Is it Sunday? Yeah, today is Sunday, and this stream we're gonna conduct from the Microsoft Office as usually, but not in the evening because evening is busy today. So thanks everyone for joining. Agenda for today. Step 1, I'm gonna drink this whole cup of coffee. Then quite some interesting stuff happened, as I already said in my Telegram channel. My friend was performing or had interview at Meta, and this was interview for Linux troubleshooting, and this was quite interesting for him. It was his first time. I also never had this kind of interviews, and this is something I want to share and discuss because it will not be exactly the same question, but it will be presented in a similar fashion, and I will show you what you generally should answer when you have this type of questions asked. Usually they are asked for positions like site reliability engineer, production engineer, stuff like that, for the role which actually includes such responsibilities as taking care about production, on-call, live site, incidents, scaling, maintaining the reliability of the service, high availability, and stuff like that. So for that you might need to have some Linux troubleshooting interview, which is actually quite interesting from the feedback. So we're gonna go through this one, then we're gonna have some LeetCode today, just 2 questions, one for BFS, another one for HIP or priority queue, whatever, and system design if we have time, but I'm not quite sure that we will have one. So I think we can actually start because we kinda don't have that much time. So let me just find some question. And the question was, so maybe let's actually start, maybe let's reorder this one. Let's do like that. Oh my god, what happened? So we're gonna start maybe with LeetCode for now. And and then we're gonna proceed. So the first LeetCode question is the following. We are keep moving with our LeetCode 75 list of the questions. The basic one you should pass if you preparing for interview and you have roughly months, but it will not be most probably enough in your case. Good. I want to make sure I have everything. Yes. Okay. Good. So this is the rotting oranges. Quite I would say popular question or type of question. It uses pretty popular pattern called a level order or level-based BFS. So what is the question? We have grid, m times n grid, where each cell can have one of 3 values: 0 representing an empty cell, which we don't care about, 1 representing a fresh orange, or 2 representing a rotten orange. Every minute a fresh orange that is 4 directionally adjacent to a rotten orange becomes rotten. Return the minimum number of minutes that must elapse until the cell has a fresh orange. If this is impossible, return 1. So, first example, we're gonna draw a bit, just a bit. Actually, if you know the pattern already or you know some of the graph theory, it's gonna be quite easy for you. Let me also open my I started my LeetCode related doc because I got quite overwhelming with the number of different algos and topics I have to keep in my mind. So we're gonna use it, and I'm gonna show you straight away here everything that you need. So with regards to drawing, okay, so in this case you can see that this guy is rotten. So 0, 0 index is actually rotten. And what we're gonna do about this? So how it works? This is minute 0. This is our starting point, our starting state. This is 3 times 3 grid. And we have one rotten orange. We can move only to the right, bottom, left, and up. So only 4 directions. Since this is 0, 0 index, we cannot go up and left because it will be index out of range. So the only 2 directions we're gonna go is right and left, and we're gonna rotten these 2 oranges as well. And this will be it. This is like the first minute. It passed. Now it's minute number 1. We see these guys are already rotten, and they also try to go 4 directions each. So this guy moves these 2 directions, this guy moves these 2 directions, and we can clearly see that these 2 oranges are going to be rotten the next. And this is exactly what happens. Now this guy can try to go these directions, but to the left it has already rotted the neighbor, so it actually does nothing. Bottom is empty cell, and these 2 are out of range. So only this orange gonna kinda infect another one which is below, because it cannot go this way. This guy becomes rotten as well, and this is gonna be the last minute. This guy infects the right one, and in 4 minutes we have everything rotten. There might be the situation where we actually cannot rotten any oranges, which should be the situation in case if we have here empty cell completely. Then there is no way we can reach and infect this orange. It is safe, we should return -1. So how do I proceed with this problem at the moment? So we're gonna traverse the whole grid, and we're gonna remember the rotten oranges, because these are the guys who will trigger the infecting of others. And then we're gonna process every rotten orange and try to explore it in a BFS way, breadth first search, because this is the natural way of doing it. This is how it works. So you basically start with some orange, let's say this one, and you try to explore the closest neighbors, and you put them into the queue for later exploration, because the next minute they're gonna be rotten as well, and they're gonna explore their neighbors as well. And you're gonna proceed up until you have something to proceed, or until there is fresh oranges as well. So this is gonna be the algo. Let's just code it up. So for the simplicity, I'm gonna do this because I'm a bit confused, since I had bachelor and master's some years ago. Actually, matrix is gonna be presented m and n. So yeah, instead of having n and m, I just gonna do it as readable as possible in terms of variable naming. So now we have rows, we have columns. Can you see it actually well? Yeah, you can see it well. Like that. Exactly. Nice. So now we're gonna just traverse everything and just remember 2 things: how many we have fresh oranges, and put everything to the queue for the rotten oranges. So I'm gonna have queue, the queue, and now for the row in range rows, for column in range calls, we're gonna do what exactly? If the current cell has fresh orange, which means it has 1 as a value, we're gonna just add fresh ones plus 1. So it's gonna be fresh plus equals 1. Else, if this guy has rotten orange, we're just gonna add it to the queue. And we're gonna use tuples for now, because we want the coordinates, not the value. Now, what's gonna happen the next? After we traversed everything, yeah, exactly, we're gonna do level order PFS. Yeah, this guy I already noted. This is how we're gonna, one of the methods to explore the nearest neighbors and to count how many hops we did already. So this is something how it's gonna look like. So we have some queue, and every single time we only process the number of items that we added during the previous iteration, kinda. So we're not gonna process more than current length of the queue. And after every single whole queue processing, we're gonna add level. Yeah, as simple as that. So we're gonna do quite similar thing. The only thing that we don't have to have and to track visited nodes, because we can use the grid itself. There is nothing stating that we cannot update the input. So how we're gonna proceed? Yeah, so while length of the queue more than 0, we're gonna proceed. Let's remember the size. So length size, and for range of this size, we're gonna pop the items, number of times which queue has at the moment. So our row and column gonna be queue pop left. Then what is going to happen the next? We have our current row and column. What we're gonna do, first of all, we're gonna mark it as a rotten. No, it's already rotten, right? Because after this traversal, the queue will have only rotten the orange, so we don't even have to mark it, which is actually a good thing. And now I would believe we can just explore top, left, right, and bottom. So delta row, delta column in. So to the right is gonna be the same row plus 1 column. To the bottom it's gonna be 1 row and 0 for column. For the left it's gonna be same row minus 1 column, and to the top it's gonna be minus 1 column, minus 1 row, 0 column. And exactly, new row gonna be row plus delta row, new column gonna be column plus delta column. Now that we have these new coordinates, what we should check first of all is that we are not out of range. So first of all, what we are checking, if new row less than 0 or new row more than or equal our rows, or same happens for the column, if it's 0 or it's more than equals, then in this case we just continue. We're not gonna process even it. Now, next thing, if it is still, if it's not an empty cell, because empty cells we don't want to process at all, and if it's not already rotten orange, because we already processed it, there is nothing to do. So if create new R, new column is not equal to 1, which is exactly fresh orange, we're just gonna continue as well. And only in other case we're gonna mark it as rotten, because it's gonna be rotten the next minute. So new row, new column, gonna be 2. Now this is rotten. This is kinda visited set in our case at the moment. Yeah, so we're marking it. And also what else we should do, we should decrease the fresh number -1, and we should add it to queue. New row, new column. Great. Great. And after that, after we perform the for loop completely, what we should do actually, we should increase the number of minutes. So initially the number of minutes is 0. but then the number of minutes, indentation, sorry, number of minutes gonna be plus equals 1. All right, so let me check this one. Fresh can be Q, yes. Yes, seems like it. Seems like it. And in the end, oh no, also we should add fresh more than 0. Yeah, if there are no more fresh, we don't have to proceed at the moment. And in the end, what we're gonna do, we're gonna just return the number of minutes if fresh equals 0. In other case, we return -1. Because if it's impossible, we return -1. Good, that should be it. Let me first run it, and after that we're gonna analyze the complexity. And let me just first go through. Fresh plus, we had it. Good. Q size for the range in size. Good as well. Should be good. Open it. I'm trying to explore everything. Yeah, great. Yeah. Let me try. Yes, succeeded. Yeah, quite successful. Good one. So now, yeah, now let's analyze time complexity. So actually, let's denote our n and m as two dimensions of the matrix. So basically, this for loop gives us already O n times m. For the space complexity, yeah, and this guy gonna process only, in worst case, all cells, which is also n times m, which is going to be 2 times n times m, and constant is going to be removed, so it's just n times m. And for the space complexity, since we are modifying and we are tracking our visited set in this BFS solution, instead of additional space which is modifying the input, we don't count it, and only another extra space which is not constant in our case and depends on the input is q. And in the worst case, q will have also all items, because our whole matrix can have all rotten oranges that we're going to add here. So no, in worst case, it's also n times m. Yeah, so this is the question. Nicely done. We're gonna move on, and this is kind of jokish medium question. It shouldn't be medium in my opinion, but with the follow-up, it can be medium. I agree. So, Kate's largest element in an array. Given an integer array nums and an integer k, return the Kate's largest element in the array. So, yeah, element in sorted order, not the Kate's distinct element. Which is good. So we don't have to care about duplicates in this case. So first thing how you can solve it straight away is as easy as that. So you basically gonna go sort the array and then return array nums minus k. So in our constraints we see that k will be at least 1, which, and at most, do we have guarantee that it is largest? Yeah, I think we have guarantee that it should be in the boundary of the array, so this is actually the answer. So you sort in the array and pick the Kate's element from from the end, and this is the solution already. In this case, the complexity gonna be of, so sorting usually not gonna be something better than log n log n. And for the space, it depends also on sorting algorithm. If it's merge sort, it's gonna be, I believe, n. Yeah, and if it's quick sort, it's gonna be constant, but then worst case for this guy gonna be n squared. So it's a trade-off. I don't know what sorting algorithm Python is using underneath. And another way of doing it is actually a bit better and trickier. So let me show you. It is using the heap. Using the heap, so we have our heap. And actually, yeah, I switched to the Python lately. So before that, for all my LeetCode questions, I was using the JS, and lately I switched to Python, and I believe this is actually the best choice for the algo questions. And actually, yeah, you all people were completely right about this. But the thing is that it's, yeah, in JS we don't have heap at all and priority queue as a data structure. So instead of it, you're going to use just array and sort every single time you're inserting the item or popping item. No, for popping you don't have to, only after insert. And yeah, for .NET it's much better, but yeah, heap in the Python, it's completely strange thing to me, because for a heap in the Python you should declare your array. And then you're gonna use structure like this, here pq, heap q, whatever. And this guy gonna perform the operations on the heap array. This is how it works. So what is the algo in this case? So there is kth element. So what you can do, you can keep the priority queue with the length of k. And you're gonna keep it that length. And that length, and process all the items. And in the end, you're actually gonna have, whenever you, so it's kind of a sliding window or something like that. So in case you have k equals to 4, let me show you actually and draw this. So you're gonna have priority queue, and you know the priority queue is pretty good data structure if you need to have elements kind of sorted. It's one of the way to sort the elements in general. And also what it gives you pretty good constraints for the getting the minimum element out of all the whole array and inserting it. So insert gonna be height of this heap. So what is the algo? K is 4. It means if we have some array of numbers here and there, what should we actually return if it's sorted this way, right? And this is the k. What we should return is this, the lowest element in this maximum range. So we're gonna keep our maximum range up until the end, and after that we're gonna just get the minimum one from it, and that would be it. Yeah, I believe. I don't know what happened to use, but usually streams should get like 10, 12, but now we have 4 people watching. It's something actually strange, a bit, but yeah, whatever. All right. So how it's gonna be implemented, I'm not gonna even use my VS Code with Vim. So you define heap, and then you traverse nums. And what you are generally doing here, heap push, I think this is the thing. So you are pushing the number, and in case your heap len heap is more than k, which means you're out of your window, you just do heap q, heap pop. Oh, sorry. I think this should be it, right? Yeah, and in the end, once you traversed, the lowest value that you have is gonna be your case largest number. So you just return heap 0. Yeah, sorry. Yeah, you always need to pass this, your underlying data structure for heap, which is like weird in my opinion. Why they cannot encapsulate in some wrapper or something, I don't understand this. Anyway, yeah, this thing also works, and the time complexity here gonna be O times n, since we're gonna anyway traverse all the numbers, but times log k, not log n, because now it depends how big window we have and how many items do we store. Additionally, it depends on the k, because we're gonna store exactly k elements. So for the spacing, we're gonna have k. And that will be it. That will be it. This is the problem. Keep it going. Love from India. Thank you. Thank you. Yeah, I believe that should be it. That should be it for now for LeetCode. Next question we're gonna do next time. So, right now let's move forward with our initial plan. So now real metal Linux troubleshooting interview. Let me actually go and find the question that my friend has had. So it's gonna be something like, yeah, it should be empty. Let's make it empty. Markdown, please. Yeah, thank you. So this is going to be the question. Yeah, you're on-call engineer for the website on the hostname.com, whatever. It's not relevant actually. The website is deployed on the single. Yeah, let me also add this thing for the newcomers that will join the stream. So yeah, this is the question. You're on-call engineer from the website of the hostname.com. The website is deployed on a single data center and single machine. It has front-end app, back-end app, and database. At 2:06 a.m., you're getting alert that website is down, and you don't have any idea about what is the technology stack, how it is deployed, etc. You know that alert works by just simply curling CURL in your host. You're getting root SSH access to the site. The task is to find the root cause, fix it, provide recommendations to prevent it in the future. So imagine you're given this type of question and you have no actual idea what to do, actually, what to do. So in general, yeah, this question is about your knowledge of the Linux commands and yeah, working with terminal, knowing the operating system, processes, and stuff. Yeah, and also about your troubleshooting process overall. So general guidance, how you should process is first, you're gonna, from the external terminal, you're gonna check the connectivity, because it can be some, it can be firewall, for example. Some deployment. You don't know anything. Maybe somebody has just deployed something and it broke whole production, right? You don't know. You don't have metrics and dashboards. You should find out everything on yourself. So first thing what you're gonna do is to ping hostname.com, CURL hostname.com, and if you know the port, which is gonna be 80 actually, also would be a good idea to check it. And maybe let's even run these commands, as I have WSL on my machine at the moment. So yeah, I think I can pull this terminal up here. Yeah, so first of all, in this type of situations, and the type of interview in this case is that you don't have anything, you don't have access to shell or something like that. You have just some, I don't know, editor, or you're just talking with the interviewer, and what you are saying is the command you want to run, and the interviewer says you the output the output of this command that will be provided to you, but you don't even see it. He's just telling it to you. Quite complex, to be honest, quite complex. So yeah, first thing what you're gonna do, you're gonna ping in. You should see something like that. It means site is reachable. Yeah, on the host name, it can be actually blocked by a firewall. You can specifically block ping requests, and I actually explaining you how to do it here, because these are ICMP requests, and you can basically block them. But if not, if they are even blocked, you're still gonna check it by doing curl google.com. Yeah, and if you have some output, it means okay, at least DNS works. This is already good thing. And then you're gonna check telnet, which gonna check the port. Usually it's 80 or 443 for HTTPS. Please, how? Wait. Okay. Okay, and that's also for sanity check 443, yeah. And it is also telnetable, I would say it's telnetable. Then after you check the external connectivity, you go to on the host, you SSH. If you can do SSH, at least the machine is basically working, it's not dead. This is already good news. Yeah, also what you should ask whether there is single machine or multiple machines, but in this case it's single machine, single data center, single everything. So in this case, what you're gonna do, I would actually usually assume that how I deployed the applications for my personal projects and stuff like that. I usually use the Docker completely, because yeah, if you're wondering, like for me, the simplest thing how to do it is that you have some Docker installed on the machine. This is your server. You have Docker here. You don't have to install anything, any dependencies, anything at all. So if you're too lazy or you have to literally the MVP, what you're gonna do is actually from your local machine, you're gonna build a Docker image, push it to some Docker registry. It can be even your GitHub, so it is for free. And from the server, using the Docker, you log into this registry, pull in the image, and do Docker run or Docker compose up, stuff like that. So on your server, you're just maintaining the Docker script. This way, if you're even moving to next machine, what you need to do is install Docker, log into your Docker registry, and your machine can basically serve all your needs. Something like that. This is how I'm deploying usually, and this is the pretty much most common way, I guess. So what I'm doing usually, yeah, I would do Docker PS. But yeah, Docker could not be found, and this was also the answer. So if you don't have Docker, what you can also check, where is my Ubuntu? Okay. You can also check, yeah, now this is the problem, because right, you usually don't expect to have, usually contrary, you're expecting to have some Docker. But if you don't have Docker, it means the server and like the app, whatever, it is running as a usual process. So most probably they pulled code, built it, and deployed it, or something like that. So second assumption can be that, okay, usually for some web technology, the Nginx reverse proxy is used because it gives you a lot of benefits, a lot of control, single entry point, stuff like that. So what you're gonna usually do is to go to etc and find here the Nginx, but it is actually not installed in my WSL distro, but usually you're gonna find it and you're gonna check some configurations, what it listens to and stuff like that. So let's assume that the answer is that this Nginx actually listens to external port 80 and forwards to internal port 8080. What I mean by internal port, that there is something like localhost 8080 where the request is forwarded to. Good, but it doesn't say you anything because you still don't know what is the directory of the application, what is the binary that is listening to this port and stuff like that. So to check this, I guess netstat should be netstat should be the answer, but unfortunately I'm not listening anything either on my local WSL, so I'm just gonna quickly go to my personal VPS. Yeah, and then I will show you actually how usual output gonna look like. Yeah, and it should actually give you either the path or path of the. Actually, let me check the process. I'm gonna check with you how to check the process on Linux that listens to some port. Process ID or path of the binary. Yeah, something like this. Am I Russian speaking? Well, I can understand Russian speaking, but I don't speak Russian. I speak Ukrainian or English, but I can understand what you are writing. Okay. ls off. Yeah, so this is what I was talking about, and let me actually check. Yes. Yeah. So this is how usually it's gonna look like. Yeah, I will just show you the screen for the security purposes. So yeah, usually after running this netstat with a good amount of arguments, what you're gonna see is that you have the ports that your server is listening to. These are external ports, right? And the PID program name. So you have this PID. Here it is. So yeah, this is PID and this is program name. So in my case, for like in my personal server, yeah, as I told you, I'm running everything on my Docker because this is very convenient. But in that case, for this interview, there was no Docker, so we're just gonna check the process. And this is good thing that we found first the port it is legit listening to. So what we found is that this internal port and the PID of the process that listens to this port. And now what you're gonna look up the process binary, you're gonna use PS. So yeah, back then my friend didn't have any access to ChatGPT or Google, so he just told I would use some PS with some arguments, and this is gonna give me the binary pass. So how to check the binary pass of the process by PID? Read link. Oh, well, I'm not sure. Can I use PS? Oh yeah, I hate this. So PS minus P. Exactly. So I'm gonna just run it on my local server right now. Yeah, and then show you the output. Okay, like this. Yeah, so actually what I can see, yeah, I'm sorry, this is for security purposes. I don't want you to do anything with my server, so I'm kinda, yeah, don't want to show the whole terminal to not reveal something. So this is what you would see. You're using PS, you're using the PID, the process ID, and what you're gonna see is that, yeah, it host port, blah blah, container IP, container port, and what you see is the binary, so Docker proxy. If you're not running it with the Docker, then the binary pass would be actually the binary that is running this port. So what you're gonna do in your interview is to go this, I don't know, up pass, whatever, and then check whatever you have inside. Maybe you have some configuration, maybe you have some pass to the logs and stuff like that. I just found your channel. How old are you, and how old are you in IT, if you don't mind me asking? Yeah, sure. I'm not. So I'm 25, and in IT I'm already for 7 years. I think next month it will be precisely 7 years. Yeah, and right now I'm working at Microsoft. We are at Microsoft office here. It's weekend, so I'm alone, but I'm in my open space. Yeah. So yeah, you're gonna do to this app, and let's say your interviewer is telling you, okay, there is pass to the logs, and there is some configuration which doesn't seem really relevant. So you go to the logs, which is actually logs, by the way, are stored usually in the var/logs from the root directory. So var logs, or not logs. Oh no, just log, exactly. Yeah, and you have bunch of directories that are emitting these logs. So let's say you found the logs, and the error for the app that crashed basically, and that is not responding, the error is something like that. So stuck writing to file descriptor. So there is some input-output operation that is performed, and basically it is stuck because, well, yeah, because it cannot write. So something on the OS level that forbids it to write, or I don't know, it cannot write basically. So that's good. Maybe app is writing something to file. Maybe this is the database which tries to write. So in general, if there is the problem writing to file, there is problem with the disk, and might be the problem with the disk. So what you're gonna do usually is to use command such du, which is disk usage, with some bunch of arguments which can show you, I think, how many space is occupied by specific folder. And yeah, after my friend said it to interviewer, what was the answer is that let's assume there is some big spike of the occupied space in exactly this directory. So you can narrow it down from the root. And you see that basically up logs is occupying pretty much all the space, and you run out of space basically. So this is now pretty much the root cause. You also can check the htop, which gives you the system system metrics. So the number of cores and other stuff, and you can check a bunch of stuff. So in my case, htop or just top showed me that I have high volume of CPU usage for the weight, which means, yeah, there are a bunch of input-output operations that are stuck. And this is exactly what the answer. So after that, you just rotating the logs or backupping the logs and just manually dropping them, doesn't matter, and system got recovered. And this was kind of the interview. Good. First time we're actually on time. It's only 1 hour passed, and we already did pretty much all our plan. Now we're gonna move to system design. Yeah, so you are preparing to a meta interview or something. No, I'm not preparing to anything. It's just my friend had interview, and I just found similar interview that is really close to what he had, and show the way how you're gonna approach this interview. But no, I'm not preparing. I'm just getting my skills back. So we're solving LeetCode, doing system design on the streams at the moment. So yeah, usually this is how it goes on the streams. Now the system design, as you can maybe, as you remember, previous time we still are doing this URL shortener. So our system design at the moment is the following one. So yeah, should be scalable, highly available, and blah blah blah. So what we end up, the best solution for, or one of the best solutions that there are for your URL shortener in system design is to use 64 bits numeric, or basically number of the size 64 bits, which is long, and you're getting this number, you're running base 62 encoding on it, and you're getting some characters. Why 62? Because it eliminates some of the unsafe characters for URL, and this is going to be your pass part for your URL, for short URL, and then you just store the mapping between short URL and long URL. What you do on the read is you're just getting this mapping and redirect to the long URL, and that's basically it. The tricky part here is to how to generate unique IDs of 64 bits and actually ensure that they are unique. And this is the hard part. So what we end up doing is to use the well-known algorithm called Snowflake ID, which is basically a stateless way of generating the IDs. Yeah, just change the sound exactly. Which is the stateless way of generating ID. So how it works? Do I have it anywhere here? No, I don't. So, okay, in short, it works in the following ways: that you have 64 bits, and you split it on some compartments. It works basically the same way as a general universal ID or unique universal ID. So this UUID thing. Actually, it does not work anymore like that, but first version of this GUID and UUID was working like that. So first compartment is going to be timestamp, milliseconds based. For more capacity for your IDs, you're gonna change the epoch from Unix based, which is 1970. The number of seconds that started from 1970, you're gonna change this epoch to 2024 or whatever. So you start with the real number, which means you have more capacity for the timestamps. So this, I think, 41 bits as far as I remember. This guy gonna be machine ID, and the rest is gonna be sequence number. This is only for cases when single machine got couple of requests in the same millisecond. Then we have monotonically increasing sequence number, which is using underneath the interlocked statement, so we are not using these large and very high weight locks. We don't lock threads, we're just using lightweight mechanism for synchronization. Actually, what can I say, that we already implemented this unique number generator in my repo, so you can basically go and check the implementation. Yeah, on my streams we are not only designing, but we're also implementing the system designs that we did, at least some MVPs. So this is a Snowflake auto increment. Everything is here, you can set it up, and also your URL shortener is basically ready, we finished it. And now, yeah, having this ID, you're doing base 64, putting it to the cache, and then reading it from the cache and doing redirect. As simple as that. Now we're gonna check some of the already explained implementation on the YouTube and compare how do they perform comparing to our solution, what are the flows and stuff like that. So URL shortener, system design. Let me find it. And we're gonna review it. Oh, that's cool. Thanks for sharing. If your streams are available after stream ends, yeah, they are saved, so you can check it later. The recordings are saved for sure. Yeah. Okay, there is system design from LeetCode, the guy who I was watching for some LeetCode problems. Actually, I'm enjoying it. So, yeah, let's check two of them, because some of them we already checked. I was not really happy with the solution. So first of all, let's start with this guy, and yeah.
System design interview question: design a URL shortener, for example, like bit.ly. And before we get started, I wanted to mention that this is actually in partnership with System Design School, and there will be a link in the description to this so you can check it out. And there's a structured way. And so that's what I'm going to be going through. But before URL, it was this, and so what that did is it returned a
yeah, this is actually a good explanation of like what is going to happen, like from the perspective of the customer.
Redirect. That's what 300. The first thing that you generally want to do is like it'd be very easy for us, for example, to create like a YouTube.
Well, actually, I don't think this is the correct one how to approach the system design. First, get the requirements, that's true. Then you should do high-level design, which is a couple of squares. And then you're gonna do API design, database design. Basically, I would say database design is not that important. I would say mostly it's not actually important because this is a discussable thing. What is important to at least ensure it's gonna work, and it's gonna work on a high scale. And usually database design is not that important for ensuring high scale.
YouTube clone. So that's a little bit vague. It doesn't say the exact
minimize redirect latency,
latency
okay.
that we're looking for. Maybe we can try to clarify that with our interviewer.
Usually the problem is within the non-functional requirements, because usually what you're going to get on the system design interview is that you have millions of the requests. You should be up 100% of time, and you should be also, you should have low latency and stuff
But
like
I think
that.
in our design, it will be pretty obvious where the bottlenecks are, and we can create. We'll talk about that later.
So 100 million daily users, 1 billion reads per day, 10K requests per second. It's actually not that high. Like 10K requests per second, it's low. I mean, on my server, like on my service that we are working on, it's more. 1 to 5 billion total lifetime URLs, which should be completely enough if we use this 64 bits number.
So now,
okay, the non-functional requirements are actually easy. Like link analytics, this is like whatever. Usually this is not something that people are asking, maybe as a follow-up question. The two main functional requirements for your URL shortener are usually these two.
We want every
So,
the two
how are you
endpoints that
gonna
we
ensure
decided
uniqueness?
on.
This is
To
like
start off with,
most this interview like scenes on the YouTube, they fail on one thing. Like, okay, they almost all of them come up with the solution that okay, you need unique number, and most of them fail on the unique number generation. And I think the North Star here is Snowflake ID generator, which is basically North Star because it is used in the large-scale systems like Twitter, Discord, Instagram. So all big tech companies are already using this algorithm. So whatever else, most probably doesn't work. Otherwise, they would be using it.
I'm going to keep it that simple. We're going to call this our, also, you guessed, a web browser, which is I show to create my case being made. Probably don't want to. And maybe we want to store them on big part of that. We're going to URL and having things either scaling.
Okay, like for high-level design, usually legit this is enough.
The amount thing of the
That's okay. That's okay.
functional requirements to share. First time it would hit the redirect.
Okay, API gateway can be, but like, what is the purpose?
Those, but a bit subjective, simple enough that
Yeah, one important thing for the system design: never put or like for any type of the interviews, never put or never do something that you cannot justify well enough. Never do something that you remember usually is done. Never do template stuff. Always write lines of code that has some purpose and you have reason to write them, and always do the same for system design. Don't put extra layers, don't put extra services if there is literally no reason for that. It does not improve anything, it doesn't bring anything into the plate, you know.
that a single service is probably fine. Like we don't need to go crazy and have a microservice here, 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 and here to handle small operations. It's fine, in my opinion, to consolidate the endpoints that we have into a single service. But oftentimes in system design interviews and more complicated designs, we actually have something else over here. It's called an API gateway. So I'm going to get rid of this. And now
And this is bullshit, because justification that always we have API gateway without providing a reason why do we have it is bullshit, and I would put a minus for such interview performance.
I'm about to make our design a bit more complicated. So here we're going to have something called an API.
No. In your system design, you don't want to make your design more complicated. You want to make your design as easy as possible. First, for your own understanding, and so you don't mess up anything. And second, for your interviewer understanding. Because if your interviewer doesn't understand your system design, it's not good for you.
API gateway, and you might already know what it means, but the main reason that API gateways exist is to handle routing between different services and a few other things actually. That's not the only reason. There are other main reasons as well. But in our case, why would we even need an API gateway if we just have a single service? Well, you're right, we probably wouldn't. And we probably wouldn't if we had two services either, to be honest. Two services isn't really that many. But once we start increasing the number of services, the API gateway pattern can be very useful because then the client doesn't need to know about all the services that we actually have. And it doesn't need to know how to reach them and how to call them and things of that nature. So it makes the client's life easier, but it also makes it easier from the backend side, from the perspective of implementing and creating a microservice. There's a lot of common functionality that comes along with that, things like authentication, rate limiting, possibly transforming the API response into something that the client can actually accept. So we kind of move that shared functionality into the API gateway layer. It is considered a reverse proxy. And if you want to learn more about this, you should definitely check out the System Design Primer on System Design School. I will leave a link to that below. But I think that's pretty much enough discussion for like what API gateway actually does. And in terms of why we are going to use it, it's because we're actually going to split up these services. So we're going to have one URL shortening service. So I'll rename this guy here, and I'm going to copy this because we're also going to have the URL redirection service. Now, I'm sure you're wondering, why do we need to
Okay. Now justification for API gateway is kind of good. Because first what I thought about this, that he's just going to put a bunch of replicas of the same service and then put API gateway, and for the reason that you have many such replicas. But in that case, it's not called API gateway, it's called load balancer. But okay. Okay, but I guess in the beginning, didn't he say that actually we can put both of these APIs in one single service.
Do this, why would we make our life harder by creating microservices just for a single endpoint? We probably wouldn't, but I think this is worth discussing because most designs will involve something like this. And since this is kind of a beginner problem, it's worth going over some of these basics. And also in a real interview, your interviewer might ask you to do this, even though in most cases it would probably be overkill to do this. So in a real interview, I think it's worth mentioning like, hey, I know we can do an API gateway. I know we can split these services, but I think it's probably overkill. Doing things the simple way is probably sufficient. And maybe your interviewer would agree with you. Maybe they would still want you to do this just to make it more interesting, but in this case, it's probably not necessary. So now the lifecycle of a request would look something like this.
Also, it will not be a true microservice because, you know, if your both microservices are using same database and like same tables, I mean, not just same database, but have like different scopes or like using completely different tables. But if literally one microservice is putting data that another microservice is reading, you're not doing right microservices. Okay, so this is bullshit.
The API gateway, and then the API gateway will decide which service that the request should go to. It might go to multiple services in some cases, not in this case. And then once we get the response from the service, we will return it back to the client. So I think this is pretty sufficient for a start. Like this is a
but fair point that he already mentioned that it might be overkill, which I believe this is overkill. But he didn't like emphasize that this is the exact way you should do it. He just mentioned that you can do it. But okay, but just in case, if you mentioning microservices and you're telling to your interviewer, okay, this is going to be 2 microservices and you're putting 2 arrows to the same database, I mean, don't do this. don't introduce the words that you don't know about how to actually build them. Microservice, it's not a good microservice.
Good start, but now we really need to start digging deeper and talking about how we would actually implement some of these things. How are we going to kind of already touched upon how that's implemented? It's just we are going to have basically a request made. So a user is going to enter a short URL. That's the decision that through 9. This is often
okay. Now the uniqueness
the links are
going to be discussed.
Being used. That's the decision that we are making. But as you kind of saw earlier in the video, Bitly is actually implemented with a 301 redirect. So they are taking advantage of the caching at the expense of the analytics. Things get a lot more interesting with the URL shortening service because now how are we actually going to shorten a URL? And how long do we want the URL to be? We know that we want it to be short. And I don't think we even listed that as a requirement that we want the URL to be short, but I think that was part of the problem statement. So it kind of goes without saying, but I think in our case, 6 to 8 characters should be sufficient. So we have something like that to work with. Well, I think the first question becomes, and this is kind of getting into data structures and algorithms territory, in my opinion, at least a little bit. We're going a little low level. So let's say we have something like 6 characters. And for each of these slots, how many different characters could we choose? Like what is our character set? Well, let's say we're using lowercase a through z, uppercase a through z, and as well as 0 through 9. This is often referred to as base 62 encoding, or well, not base 62 encoding, but this is considered base 62. This is a character set of 62 characters. We have 10 digits. We have 26 characters and another 26 characters. That's 52 plus 10. So we have 62 different characters to go in each spot. So that's going to be 62 to the power of 6 because we have 6 slots. And this number, you probably can't do it off the top of your head, but it's a very large number. It's about 56 billion. So it definitely satisfies the constraint of having the total URLs. We should definitely be able to store a few billion total URLs. So that's good. And if not, we could always increase this. I think Bitly actually had 7 or 8 characters. So if we add one more character, take this number, multiply it by 62, I think that's going to be a few trillion. I think that's going to be something like 3 trillion. So yeah, I think we're good. 6 or 7 characters should definitely be fine. Human readable. Everything in there is either a character like A through Z or what we're going to store. But that's not super interesting to be the or anything like that. So in our database layer, what we're going to store is mainly going to be the short URLs. We're also, of course, probably going to store users, but that's not super interesting here. So I'm mainly going to be focusing on the short URL service. And let's assume that for the database for now, we're just using a simple relational database. So within the short URL, what would we want to store? Probably for each row, we have a short URL, which is going to be the string. We will also have, of course, the mapping, the long URL. Each short URL will map to a long URL, so we want to store these together. And let's say we also have the user ID of the user who created it, so that maybe they can delete it in the future if they would like to. We might have some metadata, things like created at, like, let's just call that the count, or used count maybe is a bit more descriptive, and that could be an integer. And it bothers me that I used camel case up above, and I'm not doing that here, so let me fix that. and fix this, or let's just make these snake case. So we could assume that this short URL.
Well, used count. Yeah, you should be careful with this one on a high concurrency because it might be. You might fuck up with the concurrency and then your used count will be completely wrong.
For each entry in the total number of bytes, we mainly just have a few strings and the date and an integer.
Yeah, for the purpose of this analytics like used count, I would rather perform something like event based to store the event of using the URL and then just some aggregated engine on top to be precise.
And I think it's pretty reasonable to assume that this could be stored with like 512 bytes to maybe 1000 or 1024 bytes, roughly a kilobyte. So let's assume a kilobyte just to make the math a bit more simple. So 1 kilobyte for each record, and the total number of records that we're going to have is a few billion. So let's say 1 billion, or rather roughly like 5 terabytes of data. Choice of choosing a relational database and also just choosing a single node for it was actually sufficient. If it wasn't, that would be fine too. We could try to like scale out this system, but it looks like that's probably not needed in this case. So the math tells us that we're actually good here. Now, there's a few things that are still left for us to explore, and just so I don't actually get distracted, because I can easily get distracted with a design like this because there's so many rabbit holes for us to go down, I'm going to make a list right now, and I encourage you to do something like this in your interview as well. So one thing we know is like the non-functional requirements. That's one. We will go through and try on this. Last one, because there's actually several different ways we could approach something like this. It's a very
this is the most tricky part in this interview question, how to generate unique.
That can sometimes be the case with DSA problems as well. There's definitely plenty of algorithm problems that have multiple solutions. How would we want to generate short URLs in the real world? What's actually practical? We're not just concerned with something like big O runtime. So if I were you, I would take a second to actually think about this for a second. We have the redirection handled. What about URL shortening? Well, one thing we could definitely do is just something like a counter. That's probably the simplest solution. We could have some kind of data store, whether it's a database or something else. We would probably want to do something else because databases are fine, but it would be even better to use like an in-memory structure. We could do that on the machine, but again, it's a little bit like tightly coupling something that doesn't need to be tightly coupled. So it would probably be better to have a separate, let me get rid of this down here, a separate service, or more specifically, get the short URL. The counter would basically be responsible for.
Yeah, this is basically our system design. But let's see how he implements the counter.
For that. So at a high level, what would happen is user makes a request to shorten a URL. This service, and there could be multiple instances of them, will make a request to the counter, or more specifically, read what is the count. Obviously, we're going to start at 0, but maybe in the future we'll be at something like 5,000. So it's going to take 5,000 in base 62 encoding, and it's going to say, okay, this is what I'm going to return. Not just return, but this is what I'm going to store into the database. So the long URL is going to be shortened, and this is going to be the shortened URL. This way, we ensure that we're always going to have unique URLs, because after we do that, we get that 5,000. We're going to increment the counter, 62 encoding, and it's going to say, okay, or more specifically, read what is the count. Obviously, we're going to start at 0, but maybe in the future we'll be at something like 5,000. So it's going to take 5,000 in base 62 encoding, and it's going to say, okay, this is what I'm going to be. Get that 5,000. We're going to increment the. So this is great because it's very, very quick and it's very predictable. But what about concurrency issues? Like I said, we might have multiple services going through this counter. So if two services hit it at the same time, what's going to happen? Well, luckily for us, Redis is single-threaded, so we actually don't really have to deal with anything like that. We know that with relational databases, they do have ACID properties, specifically.
Yeah, that's true. Redis is one-threaded. Yeah.
The isolation is what we care about. But we don't have to worry about that with Redis. It's single-threaded, and it's very, very fast, so we should be good when it comes to the latency.
No. This is bad assumption. This is very bad assumption because since Redis is one-threaded, imagine you're putting millions of requests per second, and it's not read request, which Redis actually designed to be good with as a caching mechanism, but it's write request because you should perform compare and set operation and increment the counter, right? So it's write load, which takes more CPU. So I wouldn't say Redis, one single instance of Redis is good here, but it's kind of skipped
latency as well. Now, one potential downside of this approach is that we kind of have a single point of failure with this counter. So what happens if the counter goes down? Well, we can't really shorten anything. I think in most cases, this isn't that big of a deal, but it's worth considering.
Really? It's not that big of a deal? Okay.
And if that was the case, well, our design would definitely get a lot more complicated if we want to actually deal with that single point of failure, because then, of course, we could replicate our Redis instances and have multiple of them. Well,
Not
if
easily.
we have multiple instances with the same counts, then that's going to run into some concurrency issues. So we would probably want to split it up such that each counter has a different set of counts that it's using. I'm not going to go super in depth into this solution.
Yes.
I mainly mentioned the counter solution because it's probably one of the easier ones to reason about, but I'm actually going to be discussing another solution. And if you want to see more of these solutions discussed...
Okay, so basically this problem is not properly covered because it's not explained how exactly, like, okay, different sets of the numbers, how you're going to also implement it. Okay, anyway.
I would check out the write-up on a system design school because I won't have time to go through all of them, of course. But the main takeaway you should get from these like different solutions that we're going to talk about is the trade-offs between and then go from there. So size 6 or 7 characters. And
randomly, it's bullshit because if we are doing a random number or random even string, the more your service runs, the more collisions you're going to have and the more retries you're going to perform.
Solution. Now, there is the possibility that we might end up with some collisions, and that is the thing that is probably the biggest drawback of this solution. But with collisions, we can still implement some like retries, and specifically what we would do is within this service, we would generate the URL given a request, and then we would check, well, is this already existing within our database? Because then we can't reuse it. We can't have a short URL mapped to multiple long URLs. That would be unfortunate and messy. So we will just basically retry, and we can just have like a loop that will indefinitely retry. And given that we have, let's say, 5 billion URLs, and with 6 characters, we could have like 56 billion, and with 7 characters, we could have something like, I think, 3 trillion. So the odds of there being a collision with 3 trillion possibilities is pretty low. And if we ever end up in a situation in the future where we are actually storing more URLs than we had expected, the solution to that is basically just to add another character like we had, which is we are efficiency. It's really, really fast. And we're going to discuss how we're going to make it really fast in a second. But what if not that big of a deal? Why? Because think about this for a second. It's not just about the numbers. It's not just about the latency and efficiency. It's about what's going to happen in the real world. Well, when it comes to redirection, we probably want that to be really, really fast. And we're going to discuss how we're going to make it 1 extra second for a user. Even 6 going to be, you're not going to show this, but I think hashing would be a little bit better. It probably doesn't make a huge, we can just days, you probably could vertically scale this, and you might be able to handle that much or even a lot more. You might be able to get pretty close to like 100K RPS because these are going to be pretty simple read operations. We're not doing complex queries or anything like that. We're literally just going to have like a select statement, like given a short URL.
For reading, you should definitely use some caching. There is no point of doing reading and going to database.
Star, where, it's probably still going to be a lot of throughput, and we might even see spikes.
Okay,
too,
he mentions cache.
And then they never end. But database, and throughput are going to be, it's fine. Why is that? It's because we're not going to be creating too many short URLs, so it's fine.
Okay, again, there is no coverage for the unique ID generation either here. So I don't like these solutions because, as an interviewer, I would actually ask, like, deal with this because this is the main flow of this counter solution. So you should be actually prepared to answer these questions. Okay, and this guy, I saw a few of his system designs. It's actually pretty good and decent usually. So let's check.
We're finally going to be getting back in 8. I looked this up on Google.
Okay, hash long here. Okay, hashing, blah, 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 characters.
Use last write wins, LWW, and my timestamp happens to be a little bit higher than his. We need about 1 trillion links. That should be good for us. So the question and things, you're probably going to have a decent amount of those. Well, in the case of a hash collision, at least on a single normal computer in our actual computer science programs, we basically have 2 options. One is that you can do something known as chaining, which is creating a with this base. We example, of course, even though we care more so about reads than writes, we are still doing a ton of writes. I mentioned there are going to be 1 trillion URLs, and as a result of that, we want to maximize that throughput. So the first question that I wanted to ask is, can we do so with replication? Can we use a multi-leader or leaderless replication schema? Because these are 2 ways of actually making sure you can speed up writes. It gives you the...
No, actually, in order to speed up writes, you're doing partitioning, not replication. Replication is availability tactic, not Scalability tactic.
The ability to write to many replicas, and as a result, you can increase your throughput. And the answer that I think is going to be the case here is no, sadly, you cannot. So let's come up with an example. Here's me on the right, Jordan, and here's a businessman on the left. We're both submitting URLs for generation to the database at the same time, and his is leading to mypresentation.com. Mine is leading to one of my favorite sites, personally. And then at the same time, you'll notice that we've got the same short link. So as a result, we have a conflict. And so when it comes to things like multi-leader or leaderless replication, it's kind of arbitrary a lot of the time how you actually end up resolving which write is going to win. So let's imagine that we use last write wins, LWW, and my timestamp happens to be a little bit higher than his, mainly just out of random luck, because keep in mind we can't even trust distributed timestamps.
Yeah,
so this server happens to have timestamp X, and this one's got timestamp X plus 1, so Jordan's write wins, and then all of a sudden this guy is reading Jordan's link. And he's saying WTF because he thought this was a business presentation. So in theory, if you wanted to play devil's advocate here, you could go and say that, well, okay, maybe a few seconds later we could have told the businessman, hey, your right is no longer valid. But at least in my opinion, this is not going to be good here because most people generate their link, they copy memory databases, their Redis databases in particular. And the gist is that you can first write to them, and then eventually, some point down the line, you can flush those out. A hash, so things should be pretty evenly distributed.
Yeah, partitioning is the right choice here, actually.
We shouldn't have to worry about load too much. Also, recall that I basically said whenever you want a short URL X and you can't get it, you basically have to try X plus 1. And so as a result, X plus 1 would be on the same partition as X, so it means that you don't have to go to another partition randomly to make that right, and it should, in theory, increase latency. So, another thing that is important to know with partitioning in general is that we probably should be using some sort of consistent hashing.
Yeah.
Reasoning being that with consistent hashing, as opposed to hashing where you basically do mod n, where n is the number of partitions with your short key.
Good. So far, very reasonable.
On this, the only thing that's going to be moving is this ring throughout. As our tiny URL, and ideally we want this to be unique, like I mentioned.
Signing URL single. Okay, this is the actual the root question here.
We've got an actual URL, a user ID, a create time, and expire time. We'll talk about how to expire things towards the end of this video, and also a number of clicks, which again we'll talk about towards the end of this video. We actually have a little bit of a problem, which is that in theory they could be both adding the same row with the same key for their short URL at the same time, and our database wouldn't be able to do anything about it. Why? Well, normally you would want to be locking on this key.
Well, you can do if it's like primary constraint, but on a high load, you cannot most probably.
But in our case, this row didn't actually exist yet before they added them, and so we don't actually have anything to lock on. So how would a database internally actually go ahead and do something like this? Well, there's two possible solutions. One of which is called predicate locks. Predicate locks are pretty simple. They're basically just locks on rows that don't exist yet, and you specify a query on that row. So in this case, as you can see, we would be taking everything from the URLs table where the short...
Actually, I never heard of this. Maybe that's true. It's cool if this exists. But again, locks are not
short URL key is the thing that the conflict was on. And so what this style looks like, in turn, is if user 1 says to log in on that field, because we can binary search that.
Okay.
There, instead of having it would speed things up a little bit. Okay, another way that we could also handle this, in addition to predicate locks, is by actually materializing conflicts. So as opposed to locking on rows that don't exist yet, what if we actually just grab the lock on rows that do exist? Well, how can they exist? We basically just write every single possible key to the database. Now you may think to yourself, oh, this has got to be a ton of writes. We have 1 trillion possible short URLs, or actually 2 trillion because there are that many combinations. Well, keep in mind that basically there's 1 byte per character, there's 8 characters per short URL, and that actually only comes out to 16 terabytes, which is really not that much in the grand scheme of things. You'll probably still have to partition, but again, not that much data. And so now when user 1 and user 2 go ahead and try to both write to the same key, user 1 can go ahead and grab the lock, user 2 is going to lose, the database is going to say try again, and then he can try with a different row. Okay, now let's talk about potential database engines, because of course this is something we want to be thinking about as well. The first thing to note is that for a problem like this, we actually don't really ever need to do range queries, maybe with the exception of a predicate lock.
This is LSM3 plus SS table versus B3. It's so like obvious the guy is just putting Martin Sklapman is designing data-intensive applications, because these are the topics that come one after another in this book. But I appreciate it. This is good. This is good that this thing is discussed on the internet. Yeah, let's talk about these things. Martin Sklapman forever.
So a hash index could be fast, but at the end of the day, we are storing about a petabyte of data.
Okay, let's skip this.
Actually go ahead and choose a database, because now we have some good parameters with which to filter our choices down. We've already said we want single leader replication. We've already planned on doing some amount of partitioning. We want a database that uses a B-tree index. And personally for me, considering the simplicity of all of it, I think that would just make it MySQL for me. I can see why someone's using here. So I personally would lean for fault tolerance, but also to speed up reads, because replication.
Okay, read speed we don't care much about, because okay, for read speed you first have index on the database layer, you have bunch of caching on top of that, and you have browser caching on top of that as well. So like I don't think that there is some problem with read speed here. Let's just skip it. How are you gonna generate? It's again read speed. What is this? Collision YouTube title. Maximizing read speed, populating the cache. Let's analytics. We don't care as well. Analytics, stream processing. Don't care as well. Clear. No, we don't. How are you gonna assign the URLs? Like, where is the algo explained? How do you generate the? Okay, maybe I missed it. Okay, link generation. I'm sorry, maybe I missed it completely.
Want to be optimization, because that is going to be the most critical part of this problem that we really need to understand. So it is possible, if we really wanted to basically just have some monotonically increasing sequence number for all of our short links. But I think that's a pretty bad idea, because then you basically need to lock on that number every single.
Oh no. Okay, this is not bad idea. No. This is not bad idea. The implementation for this that you like to use lock for this is bad, but the idea itself is actually the best for this.
Of this problem that we really need to understand. So it is possible, if we really wanted to basically just have some monotonically increasing sequence number for all of our short links. But I think that's a pretty bad idea, because then you basically need to lock on that number every single time for every single request that everyone's making, so you can actually generate that short number. Instead, what we should probably be doing is generating those links out evenly across our system. And the way that we can do this is using a hashing function. I think just to continue to make sure that we get very evenly distributed links, we should probably put in things like in the tiny URL case with the long URL, a user ID, and a create timestamp. So we've got one example of that over here. And as you can see, it's going to output some sort of string for us to use as our.
Yeah, again, hashing has main flaw is a collision. How are you going to deal with collision?
Tiny URL key. And so the question we should now.
Especially when you have like a lot of data that is like it's. So your hash output usually is much higher than 7 characters, right?
Be asking ourselves is how many characters do we actually need in our hash result? Well, assuming that we're using 0 through 9 and A to Z per character, 36 times so on. So as a result, if n is equal to 8, I looked this up on Google because I can't do this in my head, we have around 2 trillion combinations. And considering I said we need about on hash collisions, because when you only have 2 trillion buckets and 1 trillion things, you're probably going to have a decent amount of those. Well, in the case of a hash collision, at least on a single normal computer in our actual computer science programs, we basically have 2 options. One is that you can do something known as chaining, which is creating a linked list out of each hash key bucket. And the other is probing, which is saying, oh, if this bucket is already taken, why don't we try and put our value over here? Now in a database, we can't really use a linked list, so probably the only feasible thing is going to be probing. So for example, if we had, the hash 32FC1CA8, imagine this was like base 36 or something, Then the next hash to click is going to be 32FC1CA9, and so on. We can basically keep trying until we find an available one.
This is in general bad idea because like you might keep trying for a lot of time, and each single try is additional read to database, which is input-output bandwidth, CPU bandwidth, stuff like that. Another thing that I'm questioning here, but I will come up with this
Hopefully that
later.
makes sense.
It doesn't make sense.
So now the first thing I wanted to talk.
No, it doesn't make sense. Also, why it doesn't make sense to me. So generating unique, like apparently, like the solution with the unique ID generation, like Snowflake approach, is much better. It doesn't have collisions. It doesn't need to go and read next row in the database, right, in order to write it. Like the latency will be much better since we cannot have collisions and we don't have to retry. But what I also don't understand in this solution, so let's assume we have some hash that for the URL that we created, I don't know, google.com. Let's say this hash is something, I don't know, 111. And we have hash for my personal website, I don't know, .com as well. It's going to be 111. You are putting both of these to database. So it's going to be 111. It's going to be it's going to be google.com. If we are doing probing, then most probably 112 is going to be this guy. And then we just going with our bitly or whatever we create /112 in this case, and we're gonna get okay. For it will not be much of a problem. Okay. With the probing, seems like, because we convert in short URL to the long one. So we on the right side we're just going to return 112, and then the guy would put 112 as on somewhere on his social media. Users will go to 112, and we go exactly to this thing. But there is problem with the. This is the probing resolution of collisions, but if we are using this chaining, so in case of chaining, we're going to have 111 as a bucket in our database and just list of the values that collided. So I would have google.com, and after that I will have my personal website, right? The problem here is that usually when you have a hash map, you are checking what exactly is your value by checking the value with the one you're hashing. But in case of short URL solution, you don't have value. When you want to resolve your short URL 111 to your long URL, you don't have your long URL on your hand to check whether this should be google.com or Andrejka26, right? So once this guy goes into your system, and if you implement chaining as a resolution for your collision for a hash, you basically will not know what to choose about from these two. But probing would be good. Probing would be good. However, it might fail a bit because, when you resolve to 101 on write flow, you're gonna then increment this to 112 and try to write. If it's again collided, you're gonna do 113 and so on, and it can potentially be quite a lot of times you will try to do that. So but in general, I mean, this drawback with collision, it is basically handled. What the hell, why I cannot zoom out? It's handled with Snowflake ID generation approach. So I'm sorry, but I don't know why it's a bad idea. So yeah, basically overall this system design is very solid and very concise, but regarding the core idea of generating the ID, I don't really agree this is the best idea to use hashing yet. That's it. That's it. I would put like because I enjoyed this. This is the best so far that we've seen among each other. So yeah, I think for the agenda we did pretty much everything I promised to do today. Now I think I should go. I should go and have a bit rest. So thank you for being with me, whoever was with me this whole time. Yeah, it was me, Andrei, with you. Thank you so much, and see you next Sunday. Don't forget to subscribe on Telegram. I keep you updated there. See you.